Here's a question nobody wants to answer honestly. If we found a planet, rocky, warm, with liquid oceans, right next door in cosmic terms, would we actually go? Because the closest one we've ever found is already out there. And the things standing between us and it aren't just engineering problems. They might be us. 4.2 light years. That's the distance to Proxima Centauri, the closest star to our sun. In astronomy, that's practically touching. Textbooks call it our stellar neighbor, our nearest neighbor. But here's what that actually means in human terms. If you shrunk the entire solar system down, Sun to Neptune, to the size of a dinner plate, Alpha Centauri would be roughly 1.5 miles away. Not across the room, 1.5 miles outside. Voyager 1 is the fastest object humanity has ever launched. It's been flying since 1977, nearly 50 years. It's now beyond our solar system, technically in interstellar space. At its current speed, it would reach the Alpha Centauri system in about 73,000 years. That's not a typo. 73,000 years. That's longer than every civilization, every language, every written word in all of human history, combined. And yet, we've already found something there worth going to. Alpha Centauri is not one star. It's 3. The two main stars, Alpha Centauri A and B, are locked in a gravitational waltz, orbiting each other over an 80-year cycle. A is slightly bigger than our sun, shining about 50% brighter. B is slightly smaller, a shade cooler, burning with a faint orange hue. Together, they're the 4th brightest object in the night sky, visible as a single point of light, mostly from the southern hemisphere. From the right vantage point, on a clear night in Chile or Australia, you can see them with the naked eye. You have probably never noticed them. The 3rd star is the one that matters most. Proxima Centauri sits on the far edge of the system, so dim it is completely invisible without a telescope. It's a red dwarf, a class of star that makes up roughly 70% of all stars in the galaxy, yet is almost never seen by human eyes. Its mass is just about 12% of the sun's. It burns cool, it burns slow, and it will outlive our sun by trillions of years. And orbiting it, closer than Mercury orbits our own sun, is a planet. Proxima Centauri B was discovered in 2016. Let that sink in. For all of human history, every astronomer who ever tilted their head at the sky, every telescope ever built, every civilization that wondered about the stars, we did not know this planet existed until 8 years ago. It is, by every measure we have, the most important planet ever found. Here's why. It sits inside what astronomers call the habitable zone, the distance from a star where liquid water could exist on the surface. Not guaranteed, but possible. Its mass is roughly 1.07 times Earth's. Its size is estimated at about 1.3 times Earth's radius. If you stood on it, which you can't, and we'll get to why, the surface gravity would feel almost identical to home. And it takes just 11 days to orbit its star. That's 1 year on Proxima B, 11 days. But this is where things start to fall apart. Because Proxima B orbits so close to its star, it is almost certainly tidally locked, one face permanently turned toward the sun, the other permanently in shadow, no rotation, no seasons. Just one side burning, one side frozen. On the day side, temperatures likely exceed 100 degrees Celsius. The radiation bombardment from stellar flares and Proxima Centauri flares constantly, violently, unpredictably would make the surface of the day side resemble the inside of a microwave. On the night side, temperatures could drop below negative 150 degrees Celsius. Any atmosphere carried by the wind to that side would freeze solid and fall to the ground. So, where does that leave us? The terminator line. This is the most overlooked concept in all of exoplanet science. On Proxima B, there is a ring, a circular strip running the entire circumference of the planet, where it is always twilight. Where the day-side inferno begins to cool and the night-side freeze hasn't yet reached a permanent, never-shifting zone of dim, reddish, slanted light. We call it the terminator zone, and it might be the only place in the entire Alpha Centauri system where life could exist. Picture it, a planet where the sun never rises or sets. It just hangs there on the horizon, enormous red, casting long shadows across a narrow band of world. Where liquid water might pool in warm, shallow seas, where the air pressure is just enough to breathe. Maybe. Where the wind constantly blows from the scalding side to the frozen side, churning in a permanent atmospheric river. If vegetation grew here, it wouldn't be green. The light from a red dwarf peaks in infrared. Plants would need to absorb as much of it as possible. They'd likely be almost black, dark purple or deep maroon, soaking in every photon from that dim, crimson sun. If animals existed here, they'd be adapted to that permanent twilight, eyes optimized for low, diffuse light. No circadian rhythms. There's no day and night to anger one. Bodies built around radiation resistance. Because no matter how thick the atmosphere, some of that stellar flare energy gets through. Life on Proxima B, if it exists, would be unrecognizable. But here's the real question, one we don't ask often enough. What if we got there and it's empty? We've been searching for extraterrestrial life for over 60 years. Radio telescopes, deep space observations, spectroscopic analysis of atmospheric signatures. We've looked at thousands of stars. Nothing. Now we have, for the first time in history, a concrete candidate, a specific address, a rocky world in the right zone around the closest star to Earth. And the scientific consensus, if you read it carefully, is cautiously pessimistic. The flares alone might have stripped Proxima B's atmosphere away long ago. Without an atmosphere, you don't just lose weather, you lose the pressure needed to keep liquid water on the surface. And the shielding needed to protect any chemistry complex enough to become life. Some models suggest a strong enough magnetic field could protect the planet. Others suggest that tidal locking itself would shut down the magnetic dynamo. We genuinely don't know. And this uncertainty isn't going away anytime soon. Because here's the brutal math. Our current fastest spacecraft, if pointed at Proxima Centauri, would take 73,000 years. To get there in a human lifetime, say 80 years, you'd need to travel at about 5% the speed of light. To slow down when you arrive so you could actually study anything? You'd need to carry enough fuel to decelerate from 5% light speed to 0. Using any conventional propulsion system, the fuel required would be more massive than anything we've ever built. The physics simply doesn't work. This is the hard wall. Not a funding problem, not a political problem, a physics problem. There is one serious proposal that might work, not for humans, but for information. Breakthrough Starshot, the idea: launch thousands of tiny probes no bigger than a postage stamp, carrying miniaturized cameras and sensors. Use a ground-based laser array, the most powerful ever built, to accelerate them to 20% the speed of light using light pressure on a sail thinner than a human hair. At that speed, they'd reach Proxima Centauri in about 20 years. There's one catch. They can't slow down. They pass through the entire system in a matter of hours, transmitting data as fast as they can before disappearing into the void beyond. A flyby mission. Glimpse and gone. And the data they sent back would take another 4 years to reach Earth at the speed of light. So the earliest we could possibly get any images of Proxima B's surface, if we started building the laser array tomorrow, is somewhere around 2065 to 2075. That's the optimistic timeline. Here's the thing, nobody in the documentary voiceover ever says, we might go there, and it might be dead. And that would mean something profound, not just about Proxima B, but about the galaxy, about the universe, about us. The Fermi paradox, the question of why, in a universe with hundreds of billions of stars and trillions of planets, we've seen no signs of other life, has many possible answers. One of them is that life is just rare, catastrophically, heartbreakingly rare. And if we send probes to the closest potentially habitable planet in the cosmos and find nothing, no biosignatures, no chemical complexity, no hint that biology ever got started, that would be one of the most significant data points in the history of science. It wouldn't mean the search was pointless. It would mean the search was more necessary than ever. Because either we're alone, which makes every living thing on Earth incomprehensibly precious, or we're not, which means somewhere out there, something is looking back. Alpha Centauri is not just a destination, it's a mirror. And we haven't looked into it yet. So here's where we actually are. We know the address, 4.24 light years. Third planet, orbiting a red dwarf star. Potentially in the habitable zone, possibly with liquid water, maybe with life. Definitely the most interesting place in the universe besides Earth. We have a plan, a radical, physics-defying, laser-powered plan to send the tiniest possible ambassador at 1/5 of the speed of light. And if it works, and if we aim right, and if the probes survive the interstellar medium, and if the data makes it back, then in the 2060s, a child born today might see the first photograph ever taken of a planet beyond our solar system. Not a fuzzy dot, a photograph, a surface. Maybe clouds, maybe oceans, maybe that dark, strange vegetation clinging to the edge of a twilight ring on a world that has never been touched. Or maybe just rock, wind, silence. Either answer changes everything. The question is whether we're brave enough or curious enough to go and find out. If humanity launched a crewed mission to Proxima Centauri tomorrow, knowing it would take generations to arrive. Would you want to be on it? Drop your answer in the comments. Not a joke. Think about it. And if this kind of deep dive is what you're here for, the real science, no hype, no filler, subscribe. Because the next video goes somewhere even further from home.